Hey guys! Did you know that Sir Isaac Newton was one of the greatest influential scientists of all time? He published a book named Principia, which outlined his understanding of motion and formulated the 3 laws of motion. Now, let's explore together. Watch and learn!
Let's learn the 3 laws of motion by Isaac Newton. Come on, let's go. Let's discover the importance of the 3 laws of motion by Isaac Newton. Come on, let's learn. When Isaac Newton saw the apple from the tree, the apple was falling. He discovered then the gravitational force between any 2 objects are proportional to their masses and inversely proportional to the distance squared between them. The first law of motion, also known as the law of inertia, says that every object will remain at rest unless acted upon by unbalanced force. Let's say inertia, inertia, inertia is the first law of motion. Inertia, inertia, inertia is the first law of motion.
Isaac Newton's first law of motion explains how inertia affects moving and unmoving objects. Newton's first law states that an object at rest will remain at rest, and an object in motion will remain in motion, unless it's acted upon by an external force. This simply means that things cannot start, stop, or change direction all by themselves. It requires some force acting on it from the outside to cause such a change. Inertia comes from mass. Objects with more mass have more inertia. Here are some examples. Seatbelts. Think about riding in a car. Jackie fastens her seatbelt and the car begins to move. She and the car have inertia. If the car comes to a sudden stop, Jackie's body tends to keep moving forward. When the car starts moving again, her body tends to stay at rest. She moves forward because the car seat exerts an unbalanced force on her body. Inertia applies not only to your vehicle, but to everything inside it. Because of inertia, your car will continue to move down the road until some other force slows or stops it. Coin drop. In this example, we need a card, coins, and a glass of water. NICA places a card on top of the glass of water and put coins on the top of the card. Give the card a firm flick. It will fly away while the coins just drop straight into the glass. You may expect the coins to fly off with the card. However, they actually stay in the same place because of inertia. They are objects at rest staying at rest. Force is applied to the card so it moves. The coins just drop straight down into the water once the card is no longer there to hold them up.
When the urgent mass is constant. Isaac Newton. The net force vectors is the product of the bodies, inertial mass and the acceleration vector. That is why it is called the law of acceleration.
Newton's second law of motion says that the acceleration happens when the force acts on mass. Newton's second law also says that the greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object.
Sharjah has an empty bottle of soda and full bottle of it. She is putting them at the top of an empty space and going to let go of them at the same time. What do you predict will happen? The full soda can travel the fastest. The balls we're using is a baseball and paper wad. And let's get right to it. So ISHI is going to take the big ball, which is the baseball, and the mass is the baseball, and the reaction is a Jenga falling down. So what she's going to do is she's taking the ball and roll it and see. That was the cause of this baseball hitting this Jenga. Next, this paper ball has no mass, so we cannot knock down the other Jenga. So this is the reaction the paper ball coming back. And the reason what the baseball knocked down, because there is more mass and the paper ball had less mass.
Object A applies force on object B. Object B applies force on object A. These two forces are equal magnitude, but of opposite direction. This action reaction, action reaction, action reaction, action respond. Then the turtle states that for every action in nature there is equal and opposite response. Sometimes refer this law as action reaction. Whenever the force exerted is the action, the force experienced is the reaction.
Newton's third law of motion formally stated, for every action, there is an equal and opposite reaction. The statement means that in every interaction, there is a pair of forces acting on two interacting objects. The size of the forces on the first object is equal to the size of the force on the second object. The direction of force on the first object is opposite to the direction of the force on the second object. Forces always come in pairs, equal and opposite action.
According to Newton's third law of motion, as the gas is released from the balloon and pushes against the outside air pushes back. As a result, the rocket is propelled forward by the opposing force. This opposing force is thrust. When hammering a nail into a piece of wood, the hammer imparts force onto the nail, and the nail imparts force onto the hammer. But the nail is driven to the wood because there is a net force acting upon the nail from the motion of the hammer. Likewise, the hammer has two forces operating it: the downward force from your arm and the upward force from the nail. That's why when you strike the nail, the hammer stops moving at roughly the location where the impact occurs. So, if we are looking at the nail, we only consider the forces acting on the nail. If looking at the hammer, we only consider the forces acting on the hammer. These are the different systems, and this is the context in which the third law is best understood. When his body exerts downward force in the chair also exerts upward force on the body. If the chair would not have exerted force, the chair would collapse and he would not able to sit on a chair. The force of the gravity is pulling him down towards the center of the earth. But something called normal force points straight up with the same magnitude, which is why he remained perfectly still.